Welcome back everybody. In this video tutorial, I'm going to introduce reflections of graphs and tagging along our previous topic of graph transformations. And we're going to see how we can graph a completely new function after being transformed in the plane. So the second common type of transformation is reflection. This is basically where we kind of mirror functions either across the x or the y axes. On the left here is a set of guidelines that help explain how a graph is being reflected from its original state. If we add a negative in front of the function, it'll reflect along the x-axis. And if we add a negative within the function itself, it's going to reflect along the y-axis. Let's look at an example. Now we have a very basic example. Let's say we're asked to graph or sketch f of x is equal to x squared. Now x squared is simply a parabola that's going like this. And it's pointing upwards. Now we're asked to reflect this along the x-axis. So how the function is going to behave is that it's going to just flip. So kind of like mirror along the x-axis. So if the function is like this, it's just going to mirror along the x-axis. Nothing has changed. Just the fact that we added a negative in front of the function. So this is going to produce f of x is equal to negative x squared. This is our new function. We can say that this function is reflected along the x-axis. And notice if you graph the equation, you're going to notice that there's going to be a pattern change in the table of values, assuming you construct a table of values. And we can go ahead and do that with a different example. So let me just erase this. Okay. Let's say we have f of x is equal to x cubed. Now, if I were to reflect this along the x-axis, all I got to do is just add a negative here. Now let's construct a table of values for both functions. I'm going to move this here to the left. I'm going to push this up here. Okay. So for x, so this is for x cubed. This is for negative x cubed. We have a table of values for each function. So let's say at 0, well, let's start with negative 1. We have negative 1, 0, and 1. If you plug in negative 1 into the function, you're going to get negative 1 times negative 1 times negative 1, which is negative 1. Now if you plug in 0, you're going to get 0. And if you plug in 1, you're going to get 1. Now let's try the second function. You have the same set of values. If we plug in negative 1 for x cubed, we're going to get negative 1 times negative 1 times negative 1. And let's not forget the negative sign out here. Now negative times negative is positive, and then negative times negative is also positive, and then positive times positive is just positive. So our answer is going to be 1. If we put 0 in, we're just going to get 0. If we put in 1, we're going to get 1 times 1 times 1. That's just going to give us negative 1. Now let's go ahead and graph both functions. So let's start with this. So we have negative 1 and 1. So 1 unit to the left and then 1 unit down. That's our first point. We have 0 and 0 right here. And then we have 1 and 1. Let's construct one more point. If we put in 2 here for x cubed. Sorry, let me erase that a little bit. If we put in 2, we're going to get 2 times 2 times 2, which is 8. Now, if we put in 2 here, we're going to get 2 times 2 times 2, which is going to give us negative 8. So at 2, we have 8. So it's kind of going to go up all the way up to here. I'm just trying to show you how the graph is kind of behaving like. I'm not going to graph this point, but I'm just going to show you how the graph is going to look like. So it's going to look something like this. Something like that. So if we go ahead and connect the dots, the function is going to behave something like this. Now I'm using the 2 just to show you how the graph is going to behave. Because if we just look at these points, it's going to look like this is just a linear line. But if we add one more point, like 2, we're going to see where the point is going to be at exactly. Now let's graph the second function. We have negative 1 at 1, so 1 unit to the left, and then 1 unit up. And we have 0 and 0, which is at the origin. We have 1 and negative 1, which is here. And we have 2 and negative 8, which is somewhere down here. So if we connect the dots, we can see that the graph is kind of behaving like this. So what can you interpret from this? We can say that the graph has a reflection along the x-axis. All we did was mirror the original function along the x-axis. You can also look at the table. You can also look at the table of values you constructed yourself. See how the points are kind of reversed here. We have negative 1, 0, 1, and 8. Notice how each sign here is different. We had negative 1 here, we have 1 here. We have 0 and 0. We have 1 here, but we have negative 1 here. And we have 8 here, but we have negative 8 here. So you kind of get the point. Let's do another example. Assuming we have the graph of radical x, and then we're asked to reflect this graph along the y-axis. So we're asked to graph this function. You can see that since the negative is within the function, is going to reflect along the y-axis. Now we know that the graph of radical x is going to be something like this. Now if we reflect this along the y-axis, this is just going to flip this function this way. So it'll be something like this. Now assuming we're asked to graph f of x is equal to, I'm running out of space here. Let's say negative radical x plus 2. Now we can start with our basic function, which is radical x, and it's reflected along the x-axis instead of the y-axis. So instead of it being reflected this way, it's going to reflect downwards. So it's going to be like this. And then notice we also have a horizontal transformation. X plus 2 means it's going to be shifted 2 units to the left. So first of all, it's going to reflect along the x-axis, and then it's going to move 2 units to the left. So it's going to be something like this. And then 2 units to the left. So I'm going to move 1 unit and 2 units. So eventually the graph is going to end up being something like this. And this is negative radical x plus 2. So that's it for today. I'll be sure to post more videos about reflections and shifts. Please go ahead and like this video and don't forget to subscribe. If you have any questions or concerns, please leave a comment in the comment section below, and we'll see you next time.